All right, so yesterday we looked at limits and limit notation, looked at how to find them graphically and with a table. So today we're going to talk about one-sided limits. Yesterday we actually talked about two-sided limits, I just didn't call them that. But remember, we were looking at things coming in that had to come from both sides to meet at the same value. So what this says is, so far, we've looked at the value of a function as x approaches c from each side. This is called a two-sided limit, like I just said. We've seen examples in which a function approaches a different value from the left side than from the right side. This behavior can be described as one-sided limits, okay? So the notation is a little bit different so that you know if you are looking for a one-sided or two-sided limit. If you look here, this notation looks very similar to what we did yesterday. The difference is down here where it says x approaches c, there's a little negative sign up in like the exponent part, and here there's a positive sign. So if you have and it's not a positive or negative exponent, and it doesn't mean it's a negative number. It's telling you if you're going from the left, so that the value of f of x approaches a unique number, the limit 1, as x approaches c from the left, then that's going to be there. If it's from the right, so if it approaches c from the right, it'll have a little plus sign up there. Okay, so you're not looking at both sides, you're just looking at one or the other. So let's look at this example. It says evaluate each limit using the graph. So this is the graph of this function here. So this says I want the limit as x approaches 2 from the left. So as x approaches 2 from the left, what is y approaching? What's the y value? -1. So, and it's actually at -1 the whole time. It doesn't matter. It's still, the value's at -1. And then as x approaches 2 from the right, the value is a +1. Yesterday, if I'd have just said, what's the limit as x approaches 2, the answer, it does not exist because they don't come to the same thing. But if you look at it as one side or the other, and it doesn't have a value at 2 anyway. Okay, we good? All right, so just one side or the other now. Excuse me. I'm going to show you these graphs. I don't think you necessarily need to pull them up yourself. I did assign them to you in Desmos, so when you're going back and you need to look over your notes, you'll be able to go back and see the same graphs that we're looking at together. So we're going to evaluate each of these limits. So for this function, we're going to look at the limit as x approaches 3 from the left and as x approaches 3 from the right. Okay, here's what this looks like. Okay, so this is the same function that you have there. As x approaches 3 from the left, what's the limit? -2. And as I approach -3 from the right, what's my limit? -7, exactly. -2 and -7. Any questions about that? It really is pretty simple. It's not a trick, but if you're not sure where we're getting something from, let me know. All right, number 2. I want this limit as x approaches 0 from the left and 0 from the right. So as x approaches 0 from the left, what's my limit? 1. As I approach 0 from the right, -5. Very good. So 1 and -5. Number 3. Now remember these little hook things, if you have an absolute value, these very well may show up. It's just a graphing glitch. I don't really know why. No, why, excuse me. Okay, so as we approach -2 from the left, what's my limit? -5. And as I approach -2 from the right, +5. Good. -5 and 5. All right, number 4. The limit as x approaches 1 from the left. So what's happening at 1? Asymptote. And if I just said, what is the limit as x approaches 1, then the answer is does not exist, right? But if it's 1 coming from the left, my answer is infinity. 1 coming from the right, -infinity. Number 5. We want to know what the limit is as x approaches -4. So at -4, Looks like I have an asymptote again. So coming from the left, my limit is negative infinity, and coming from the right, positive infinity. Or decreases without bound and increases without bound. That's another way to say that. All right, so let's look at a trig one with secant. Okay, so I want the limit as x approaches pi halves from the left and the right. Well, if you look at your x scale, it's not in terms of pi like it usually is, right? So you got a couple of options here. One option is you can change the scale, because what we want is our x scale to be in terms of pi, right? If it was, that's how we've been seeing it. So I left it like this on purpose so you know how to go change these things if you want to graph some for yourself. So I'm going to click on the little wrench up here. And this step on the x-axis, I want to change that to pi. So I can just type in pi for pi, and it changes it to pi for you. And so now my x-axis is in terms of pi. And I can find pi halves very easily and tell that what's happening at pi halves? Asymptote, okay? So as I approach from the left, I've got positive infinity. Approaching from the right, negative infinity. Any questions at this point? Good. Okay, so those are one-sided limits. Now we're going to talk about the existence of a limit. Okay, a two-sided limit exists if and only if both the left and right side limits exist and are equal. And again, that's basically what we did yesterday. They have to get to the same point coming from both sides. Okay, this is just kind of a little bit more of the terminology. So let's look through these. Number 7. Want the limit. So you have to pay attention to the notation here. This is just the limit as x approaches 2. 2 in general. So here's 2 right here. The limit as x approaches 2. So at 2, we're undefined. But if you look at as x approaches 2, what is y approaching? Negative 2. Number 8. I want the limit as x approaches negative 1 from the right. So here's negative 1. It is an asymptote. As I come in from the right, what's my limit? Negative infinity. We've got. All right, number 9. Want the limit as x approaches negative 4. Okay, is negative 4 the asymptote? It's not, is it? If you're not sure, one thing I put in here, but I didn't turn it on yet, is you can graph the line x equals negative 4 to make sure you know exactly where negative 4 is. And if you want it to be a different color, you can press and hold. We'll change it to green. And then you can see that that, in fact, is not the asymptote, right? So since it's not the asymptote, my answer is not, or does not exist. Instead, it's not defined at negative 4, but what does it look like it's approaching? 4. Plus, you can kind of see where it intersects there, right? Another thing is on when you graph a vertical line, you get this little slider here, and this doesn't help me on this question, but you can slide this. So if you want to know what happens where x equals 5, or you want to try and find where the asymptote is, looks like the asymptote is right there at negative 3, right? So that's just something that happens there. You can slide your line around if you want to. All right, so what do we say it was 4? Okay, thank you. Number 10. Want the limit as x approaches 3. Is 3 the asymptote here? Yes. And if you're not sure, you could graph x equals 3. So what is the limit as x approaches 3? Does not exist. Good, because it's two different things there. Or left or right, or the whole thing. That's it. So number 11, want it approaching 0 from the left. So if I approach 0 from the left on this one, what's my limit? Negative infinity. 12, I want the limit as x approaches 1. What's the limit as x approaches 1? It does not exist, but it increases without bounds, so it's actually infinity is what we put. Okay, remember that was kind of a little side note there. since they're not going in opposite directions. All right, 13, I want the limit as x approaches 0 from the right. What's that? Infinity. And then the next one is just the limit as x approaches 0. What's that? Does not exist. Number 15, the limit as x approaches 5 from the left. And this one is absolute value, but you don't have the little weird hook things. I don't know why. But we're going for as we approach 5 from the left. What's my answer? -1. 16 as x approaches 1. Okay, so as we approach 1, one of the things that tripped some people up yesterday was one where the answer was a decimal. This one I think you could probably, what are we approaching here? 0.5. But the one that was 0.1 yesterday threw some people off. Remember that you can do a table, okay? So I added a table here. There's 2 ways to add a table in Desmos. I can add a table over here, but if you do that, it doesn't necessarily go with this. If I click on this here and add a table, then it's going to add a table that actually goes with this, and I can go in here and I can change my x values, which is what I did. But at 1, it's undefined. But I put in 0.999 and 1.001, and I can see that it's on either side of 0.5. So you can look at it as a table also. Excuse me. Sorry, I can barely talk. All right, number 17. As x approaches -2, what's the limit as x approaches -2? Does not exist. Very good, because it doesn't say from the left or the right. All right. 18, I want the limit as x approaches -3 from the right. As we approach -3 from the right, what's the limit? 0. Very good. So now we got some trig ones here. The limit as x approaches 0 from the left. Okay, as x approaches 0 from the left, what's my, oh, that's the right. From the left, it's what? -infinity. And this wasn't in terms of pi, but it doesn't really matter for that one, right? Because we can figure that one out. Right, so then 20, I want the limit as x approaches pi. Well, it would be nice to know where pi is. So I could change the step like we did before, or I can graph the line, x equals pi. Doesn't matter either way, so I already have this one in here, so we'll just turn that one on. So I can just graph the line, and that shows me that it is at an asymptote, not anywhere else. So since I just want it as x approaches pi, what's my answer? Does not exist. Okay. Then I want the limit, the sign of x, as x approaches pi fourths. So on this one, let's go ahead and we'll just put in a line again. We'll say x equals and then pi fourths. All right, so I can tell you that the limit exists. Would you agree with that? I mean, I can tell it exists. So I need to figure out what's happening there. Well, when I actually get there on that point, I get pi fourths and then 0.707, but I probably don't want a decimal. Look at your function. If it actually exists, can we just substitute it in? What's the sign of pi fourths? Square root of 2 over 2. That's my answer. Square root of 2 over 2. 22, the limit as x approaches pi fourths from the right. So this time, just to remind you that there's different things we can do. We'll change the step to pi. So I can see that if this is pi halves, this is pi fourths. So what do I have at pi fourths? An asymptote. And so that means if we're approaching it from the right, what's my answer? infinity. All right. Then the limit as x approaches pi 6 here. So let's just, I think I can usually see pi halves, pi fourths, so I think pi 6 I probably want it as an equation. So I'm going to do x equals and pi over 6. Okay. You don't have to change the color, but it makes them feel better. I can see clearly that it exists, right? Right there where they intersect. But again, I get some decimal. Should I probably be able to get, with a pi 6th angle, an exact number? Yes. So since it actually exists, I can just substitute it in. I have secant squared x minus 3. What's secant the reciprocal of? Cosine. So what's the cosine of pi 6? Square root of 3 over 2. Okay. Good. So if you don't remember what secant is, we're about to square it. So if I flip it over, even if I leave the square in the denominator, it's fine. Okay, totally fine. So secant is going to be 2 over the square root of 3 squared minus 3. So squaring a fraction is easy. We square the numerator and denominator. So this is going to give me 4/3 minus 3. Need a common denominator, so I'm going to change that to 9/3. So my answer ends up being negative 5/3. Okay, we good? All right. Last one. The limit as x approaches 0, so I probably don't have to change a step or anything since I'm at 0. As x approaches 0, what's my answer? Does not exist. Good, because they're different. All right, any questions at this point? We all good? All right, so your assignment is in Delta Math, so the graphs and everything are in there. But remember, I did assign this Desmos to you if you want to go back and look at the graphs along with your notes. I mean, you don't have to. If you never go back and touch it, it's fine, but it's there if you need it. Okay? Any questions? All righty.